Structure number 1. Pumapunku, Bolivia. High plateau in the Andes Mountains. Altitude 13,000 feet above sea level. An ancient site called Pumapunku, part of the larger Tiahuanaco complex. Pumapunku means door of the Puma in Aymara, built sometime between 500 and 600 AD, maybe earlier. The dating is uncertain because the site has been extensively looted and disturbed. What remains at Pumapunku is extraordinary. Massive stone blocks, some weighing over 100 tons, carved with precision that shouldn't be possible with Bronze Age tools. The blocks are andesite and red sandstone, extremely hard stone. Andesite rates 6 to 7 on the Mohs hardness scale. You can't carve it effectively with copper or bronze tools. Those metals are too soft. They'd wear down before making significant progress. Yet the blocks at Pumapunku show perfect right angles, smooth flat surfaces, intricate interlocking patterns. Some blocks have complex grooves and channels carved into them with tolerances of less than 1 millimeter. Engineers who've examined Pumapunku are baffled. The precision is comparable to modern machine work. Flat surfaces accurate to fractions of a millimeter across several meters. How? One block has a series of precise holes drilled in a perfectly straight line. The holes are identical in diameter, perfectly circular, spaced exactly the same distance apart. The precision suggests mechanical drilling, but Pumapunku was built 1,500 years ago by a culture without metal harder than bronze. Some blocks appear to be prefabricated components, designed to fit together like a three-dimensional puzzle. Standardized parts, modular construction, concepts we associate with industrial age manufacturing, not Bronze Age stonework. The largest blocks at Pumapunku weigh 130 tons. They're made of red sandstone. The nearest quarry for this specific red sandstone is at Copacabana, 10 miles away, across Lake Titicaca. How did they move 130-ton blocks 10 miles across a lake? They didn't have wheeled vehicles. They didn't have horses or oxen in pre-Columbian South America. Llamas can't pull multi-ton loads. Even if they somehow moved the blocks, how did they achieve such precision in carving them? The joints between stones are so tight you can't fit a razor blade between them. No mortar needed. The stones lock together through pure precision. Some researchers have suggested diamond-tipped tools, but diamonds weren't available in South America. Others propose using sand as an abrasive while sawing with copper. But experiments show this method is incredibly slow and produces rougher surfaces than what we see at Pumapunku. The tooling marks on Pumapunku stones don't match any known ancient technique. They look machined, as if cut with powered equipment. But powered equipment didn't exist in 600 AD. In 1945, Bolivian archaeologist Carlos Ponce Sanguinés conducted excavations at Pumapunku. He found that the site had been deliberately destroyed at some point in antiquity. The massive blocks had been knocked over, scattered. Some appear to have been lifted and moved significant distances before being dropped. Who destroyed Pumapunku? And more importantly, who had the capability to move 100-ton blocks after the site was abandoned? Pumapunku represents precision stonework that exceeds what Bronze Age technology should produce. The tolerances are too tight, the surfaces too flat, the alignment too perfect. It's engineering that shouldn't exist from that era. Moving to structure number 2. Structure number 2. Baalbek Platform. Lebanon. The ancient city of Baalbek, known to the Romans as Heliopolis, a massive temple complex dedicated to Jupiter. But beneath the Roman temples lies something much older, a megalithic platform of enormous stone blocks. These aren't Roman construction, they're something else, something the Romans built on top of. The platform contains some of the largest stone blocks ever used in human construction. 3 blocks called the Trilithon, each weighing approximately 800 tons. That's 1.6 million pounds per stone. These 3 blocks form a course in the western wall of the platform. They're perfectly fitted together, no mortar, no gaps, just precision stonework, with blocks weighing as much as 4 Boeing 747 aircraft. How do you move an 800-ton stone? Modern cranes can lift that weight, But there's specialized equipment, enormous mobile cranes that require modern engineering, steel cables rated for extreme loads, and careful planning. The ancient builders didn't have any of that. Yet they moved 3 800-ton blocks from a quarry a quarter-mile away, uphill, and lifted them 20 feet into the air to place them in the wall. The quarry still contains one unfinished stone. It's even larger than the Trailathon blocks, called the Stone of the Pregnant Woman or Stone of the South. It weighs approximately 1,000 tons, partially cut from the bedrock, but never fully extracted or moved. Why would they start cutting a 1,000-ton block if they couldn't move the 800-ton blocks efficiently, unless they could move them easily enough that they thought going bigger was feasible? In 2014, archaeologists discovered an even larger stone at the quarry, buried beneath the Stone of the Pregnant Woman. This stone weighs an estimated 1,650 tons, the largest worked stone block in the world. Why create blocks this massive? Moving smaller stones would be much easier. You could cut an 800-ton block into 80 10-ton blocks, much more manageable. But they deliberately created these megalithic stones. Some engineers theorize the massive blocks were moved using wooden rollers and thousands of workers. But the mathematics don't work well. 800 tons on wooden rollers would crush the wood. The friction would be enormous. The number of workers needed would be impractical. Others suggest they built earthen ramps and dragged the stones up gradually, but the ramps would need to be massive. The amount of earth to construct ramps capable of supporting 800 tons would exceed the volume of the stones themselves, and neither explanation addresses the precision. The Trilithon blocks fit together perfectly. The joints are tight. The surfaces are flat. Achieving that precision with Bronze Age tools on 800-ton blocks should be impossible. You can't easily adjust an 800-ton stone. You can't reposition it if your measurements are off. You'd need to get it right the first time. The Romans documented their own construction at Baalbek. They built the temples. They carved inscriptions detailing their work. But they never claimed to have built the megalithic platform. They built on top of it. Roman historians described the platform as existing before their time. Some attributed it to legendary figures, to giants, to beings with capabilities beyond human. Modern dating of the platform is difficult. The stones themselves can't be dated. Radiocarbon dating requires organic material. Stone doesn't contain carbon to date. The platform predates the Roman structures by an unknown amount. It could be 2,000 years old. It could be much older. Baalbek's megalithic platform represents construction that challenges our understanding of ancient capabilities. The stones are too large, the precision too high, the methods too mysterious. It's engineering that shouldn't exist from the Bronze Age. Moving to Structure 3 in Part 2. Structure number 3. Göbekli Tepe, southeast Turkey. Near the city of Şanlıurfa, a hilltop archaeological site discovered in 1994 by German archaeologist Klaus Schmidt. Göbekli Tepe is approximately 11,600 years old, built around 9,600 BC. That date is important, very important, because 11,600 years ago, humans were hunter-gatherers. We hadn't invented agriculture yet. We didn't have settled communities. We didn't have cities or organized labor forces. We were nomadic groups living in small bands. According to the standard archaeological timeline, complex religious structures come after agriculture, after civilization. After you have surplus food allowing specialization of labor, you need farmers to feed the workers who build temples. Göbekli Tepe reverses that timeline. It's a massive temple complex built by hunter-gatherers, people who supposedly didn't have the organization or resources for such construction. The site consists of multiple circular structures, massive T-shaped limestone pillars arranged in rings. Some pillars weigh up to 20 tons. They're carved with intricate reliefs, animals, symbols, abstract patterns. The craftsmanship is sophisticated. These aren't crude carvings. They're detailed, artistic, showing an understanding of proportion and design that shouldn't exist in 960 BC. Over 200 pillars have been found. Geomagnetic surveys suggest there are many more still buried. The excavated areas represent perhaps 5% of the total site. Here's what baffles archaeologists. Moving and erecting 20-ton pillars requires organization, planning, hundreds of workers. But hunter-gatherer groups were small, maybe 20 to 50 people. They didn't have the population for such projects. Yet somehow, they built Göbekli Tepe. They quarried massive stones. They carved intricate designs. They transported 20-ton pillars up a hill. They erected them in precise circular patterns, without agriculture, without settled civilization, without the infrastructure we thought was necessary for such construction. The stone working at Göbekli Tepe shows advanced understanding of quarrying and shaping. The T-shaped pillars are sophisticated. Carving them requires planning. You can't just chip away randomly. You need to understand the stone's structure, how it will fracture, how to achieve the shapes you want. And then there's the age. 11,600 years old means Göbekli Tepe predates Stonehenge by 6,000 years, predates the pyramids by 7,000 years, predates writing by 6,000 years. It's not supposed to exist. Not then. Not built by hunter-gatherers. In 2011, Schmidt and his team discovered that Göbekli Tepe was deliberately buried. Around 8,200 BC, someone filled in the structures with debris, covered them up, preserved them. Why would they bury a temple complex they'd spent generations building? And why does the burial itself show planning and effort? They didn't just abandon it, they systematically filled it in. Göbekli Tepe suggests that our understanding of human development is wrong. That complex organization and monumental construction came before agriculture, not after. That ancient humans were more capable than we assumed. Or it suggests something else, something we don't want to consider. That there was a forgotten civilization, advanced enough to build temples, advanced enough to organize large labor forces, existing thousands of years before we thought such societies were possible. Moving to Structure 4. Structure number 4. The Great Pyramid. Giza, Egypt. The Great Pyramid of Khufu. Built approximately 2560 BC, or so we're told. The standard archaeological explanation: the pyramid was built by Pharaoh Khufu using tens of thousands of workers over 20 years. They cut 2.3 million stone blocks from nearby quarries. They moved them using wooden sledges and rollers. They lifted them into place using ramps. Sounds reasonable. Until you look at the numbers. 2.3 million blocks. 20 years. That's 315,000 blocks per year. 864 blocks per day. 1 block every 2 minutes. For 20 years straight. Can you quarry, shape, transport, and precisely place a 2.5-ton stone block every 2 minutes? For 20 years? Without modern equipment? That's the first problem. The construction rate. The second problem is precision. The Great Pyramid is aligned to true north within 1/15 of a degree. That's more accurate than the Greenwich Observatory in London was when it was built in 1675. How did the builders achieve that alignment? They didn't have magnetic compasses. They didn't have precision instruments, yet their alignment is nearly perfect. The base of the pyramid is level to within 2 centimeters across a base length of 230 meters. That's precision of 0.001, across a foundation covering 13 acres. Modern construction with laser levels struggles to match that accuracy. Ancient Egyptians supposedly did it with string and water levels. The internal chambers show even more precision. The king's chamber is lined with granite blocks weighing up to 80 tons. They're fitted together perfectly. The ceiling consists of 9 granite beams, each weighing approximately 50 tons. These granite blocks came from Aswan, 500 miles south. How did they transport 50 to 80-ton granite blocks 500 miles? Then lift them 150 feet into the air inside the pyramid? The shafts leading from the king's chamber have been measured. They're aligned to specific stars, as they would have appeared in 2500 BC. One points to Thuban in the constellation Draco, another to Alnitak in Orion's belt. These astronomical alignments require understanding of the precession of the equinoxes. knowledge we attribute to Hipparchus in the 2nd century BC, not to ancient Egyptian builders in 2560 BC. In the 1880s, Sir Flinders Petrie conducted detailed surveys of the Great Pyramid. His measurements revealed something startling. The interior passages are more accurate than the exterior casing. Some interior features show precision of less than 1 millimeter across several meters. That shouldn't be possible. Interior work is harder than exterior. You're working in confined spaces, limited light, difficult access. Yet the interior shows higher precision than the exterior. Modern attempts to replicate Great Pyramid construction have failed. In 1977, a Japanese team tried to build a small pyramid using ancient techniques. They couldn't manage it. They ended up using modern machinery and still struggled. The pyramid's mathematical properties are suspicious. Its dimensions encode the number pi. The ratio of the pyramid's perimeter to twice its height equals pi to 6 decimal places. Coincidence or intentional? The pyramid also encodes the golden ratio phi, and Earth's proportions. The ratio of the pyramid's height to half its base length approximates the ratio of Earth's radius to its circumference. How did ancient builders incorporate these mathematical constants and Earth's dimensions into a structure supposedly built by trial and error with primitive tools? The Great Pyramid shouldn't exist. Not with that precision. Not with that construction rate. Not with those astronomical alignments and mathematical properties. It's engineering that exceeds what we credit to 2560 BC Egypt. Moving to Structure 5 in Part 3. Structure number 5. Sacsayhuamán, Cusco, Peru, above the ancient Incan capital. A massive fortress complex called Sacsayhuamán, built from enormous stone blocks fitted together with impossible precision. The official timeline says Sacsayhuamán was built by the Inca Empire in the 15th century, around 1470 AD, using bronze tools and manual labor. But when engineers examine Sacsayhuamán, that timeline doesn't make sense. The lower walls consist of megalithic limestone blocks. Some weigh over 200 tons. They're irregular shapes, each one unique, yet they fit together so perfectly you can't slide a knife blade between them. This isn't like Egyptian pyramids, where blocks are more or less rectangular. These are complex, three-dimensional, polygonal shapes. Irregular, multi-sided, each face angled differently. To fit these blocks together requires precise measurement of every surface, every angle. On stones weighing hundreds of tons, then you have to place them perfectly. No trial and error. You can't easily reposition a 200-ton stone. Modern engineers studying Sacsayhuamán estimate it would take sophisticated surveying equipment and computer modeling to achieve such precision with irregular polygonal blocks. The ancient builders supposedly did it by eye with bronze tools. The quarries for Sacsayhuamán are miles away. Some stones came from 20 miles distant. How do you move a 200-ton irregular boulder 20 miles through mountainous terrain at high altitude? The Inca didn't have wheeled vehicles. They didn't have horses. They had llamas, which can't pull heavy loads. They had manpower. But moving 200 tons with manpower alone requires thousands of people pulling in perfect coordination, and that's just moving it. How do you lift it into position on a wall? Some blocks at Sacsayhuamán are placed 20 feet above ground level. You need to lift 200 tons vertically. The standard explanation involves earthen ramps, but the ramps would be massive. The amount of earth required would exceed the volume of the structure itself. Here's a stranger detail. The different levels of walls at Sacsayhuamán show different construction styles. The lower walls are megalithic, massive irregular blocks, perfect precision. The upper walls are smaller stones, less sophisticated. If the Inca built Sacsayhuamán in 1470, why would their construction style devolve? Why would they start with the most difficult technique and then simplify? Typically, you see construction techniques improve over time, not regress. This has led some researchers to propose that the lower megalithic walls are much older, built by a previous culture. The Inca built on top of existing ancient foundations. The Spanish chronicles support this. Early conquistadors asked the Inca who built the massive walls. The Inca answered, "We don't know. They were here when we arrived." Rock analysis shows the megalithic blocks have weathering patterns consistent with far greater age than 500 years. Some geologists suggest the lower walls could be thousands of years old. Sacsayhuamán represents engineering that shouldn't be possible with 15th century technology. The precision is too high, the blocks too massive, the methods too sophisticated. Either the Inca possessed capabilities we don't credit to them, or the structure is much older than claimed. Moving to Structure 6. Structure number 6, Nan Madol, Micronesia. The island of Pohnpei. Off the eastern shore lies Nan Madol, a complex of artificial islands constructed from basalt rock. Nan Madol consists of 92 artificial islands built on a coral reef lagoon. The islands are connected by canals, a Venice of the Pacific, built from massive basalt columns stacked log cabin style. The basalt columns weigh up to 50 tons each. They're hexagonal, like giant pencils made of stone. Natural formations from ancient volcanic activity. The construction date is disputed. Radiocarbon dating suggests building occurred between 1100 and 1500 AD. Oral tradition claims it's much older. Some local legends say it's 20,000 years old. That's probably exaggeration. But the point is, the locals considered Nan Madol ancient even centuries ago. Here's the engineering mystery. Where did the basalt come from? The island of Pohnpei has basalt formations, but they're on the opposite side of the island. Far from Nan Madol, the builders transported massive basalt columns across the island, or around it by sea. Then they stacked them to create artificial islands on a shallow reef. Some structures at Nan Madol have walls 25 feet high, made of stacked basalt columns, each column weighing tons. No mortar, just precisely stacked stone. The labor required would be enormous. The population of Pohnpei historically was small, maybe a few thousand people. Did they really have the resources to construct 92 artificial islands from millions of tons of basalt? And why? Why build a complex city on artificial islands when you have a perfectly good natural island? The effort required seems disproportionate to the benefit. Local legends provide an answer, but it's not scientific. The legends say Nan Madol was built using magic, that the stones flew through the air, that powerful sorcerers moved the basalt using spells. Obviously, we can't take that literally, but legends often contain kernels of truth. Maybe the ancient builders had techniques for moving stone that seemed magical to later observers. Techniques we don't understand. One strange detail about Nan Madol. At high tide, the artificial islands partially flood. The canals become navigable. But at low tide, much of Nan Madol is exposed mudflats and shallow water. This suggests the site may have been built when sea levels were different. If sea level was lower, the reef would have been exposed land. Building would have been easier. The structures wouldn't flood at high tide. Sea level has risen over the past several thousand years. If Nan Madol was built when sea level was significantly lower, that would push its construction date back, way back, to the end of the last ice age, 10,000 years ago or more. That would make Nan Madol contemporaneous with Göbekli Tepe, built by people who supposedly lacked the organization for such projects. Nan Madol represents engineering that challenges the official timeline. The effort required seems beyond the capabilities of medieval Micronesians. The flooding suggests much greater age. It's construction that raises more questions than answers. Moving to Structure 7 in Part 4. Structure number 7. Easter Island, Moai. Easter Island, Rapa Nui, one of the most remote inhabited islands on Earth. 2,300 miles from the nearest continent. Home to nearly 900 massive stone statues called Moai. The Moai average 13 feet tall and weigh 14 tons. The largest successfully erected Moai weighs 82 tons. An unfinished Moai in the quarry would have weighed over 200 tons if completed. Standard archaeology says the Rapa Nui people carved these statues from volcanic tuff and moved them across the island between 1200 and 1500 AD. The carving is explainable. Volcanic tuff is relatively soft stone. With stone tools and time, you can carve it. The quarry at Rano Raraku shows how the Moai were carved from the bedrock. The mystery is transportation. How did the Rapa Nui move statues weighing 14 to 80 tons across rough terrain? Some Moai were transported over 10 miles from the quarry to their final positions on coastal platforms called ahu. The island has limited trees. Modern. The ancient Rapa Nui did have more forests, but even so, large logs suitable for rollers would have been scarce and valuable. Moving a 14-ton Moai requires sophisticated knowledge of leverage, friction, and balance. Moving an 80-ton Moai seems nearly impossible without modern equipment. In the 1950s, Thor Heyerdahl conducted experiments. He hired local Rapa Nui people to move and erect a Moai using primitive techniques. They succeeded in moving a small Moai short distances and erecting it on an ahu. But the experiment had limitations. They used a relatively small Moai. They moved it on flat ground. They had modern ropes, which are much stronger than ancient fiber ropes. And they struggled even with those advantages. In 1986, archaeologist Jo Ann van Tilburg tried different methods. Her team used a wooden sled and rollers. They moved a 10-ton Moai replica a short distance, but it took weeks of work for a distance the ancient Rapa Nui supposedly covered regularly. More recent theories suggest the Moai were walked upright, rocked side to side while being pulled forward by ropes. Teams in 2012 demonstrated this method could work. They moved a replica Moai short distances by rocking it, but that method requires exceptional balance and control. The Moai must not fall over. If an 80-ton statue falls, it breaks. You can't easily repair it. The ancient Rapa Nui would need to be extremely skilled to successfully walk dozens of massive Moai across miles of rough terrain without accidents. Here's another mystery. The ahu platforms, the foundations where the Moai stand. They're constructed from precisely fitted stones. Some stones weigh several tons. The fitting is tight. The platforms are level. Building these platforms requires engineering knowledge. You're creating a stable foundation capable of supporting 80 tons. On an island subject to earthquakes. The Moai need to remain standing despite seismic activity, and the island's isolation makes it stranger. Easter Island was settled relatively late in human history, around 800 to 1200 AD. Within a few centuries of arrival, the Rapa Nui had developed the skills to carve, transport, and erect hundreds of massive statues. That's rapid development of sophisticated techniques. The oral traditions of Rapa Nui say the Moai walked to their positions through mana, spiritual power. Again, we can't take this literally, but it suggests the transportation method was impressive enough that later generations couldn't explain it in simple terms. Easter Island's Moai represent engineering achievement that seems disproportionate to the island's resources and population. The scale and precision suggest capabilities that challenge our understanding of what a small, isolated society could accomplish. Moving to Structure 8. Structure number 8. Longyou Caves, Zhejiang Province, China. In 1992, a local villager decided to pump water out of a pond. What he found underneath shocked archaeologists. The Longyou Caves, a series of massive artificial caverns carved from solid sandstone. 24 caves discovered so far, each one enormous. High ceilings, carved pillars, extensive rooms. The largest cave has an area of over 3,000 square meters, 30,000 square feet, with a ceiling over 90 feet high, all carved from solid rock. Underground. The precision is extraordinary. The walls are smooth. The pillars are evenly spaced. The angles are consistent. This isn't natural erosion. This is deliberate excavation, planned architecture. The amount of stone removed to create the Longyou Caves is estimated at nearly 1 million cubic meters. That's over 35 million cubic feet of sandstone. Excavated, removed, carved into precise rooms and passages. Where did the stone go? 1 million cubic meters of sandstone is a lot of material. You can't just disappear it. If it was removed from the site, there should be evidence. Debris piles. Nearby structures built from the excavated stone. Nothing has been found. The million cubic meters of stone is gone. No one knows where it went. The excavation method is unknown. The walls show parallel chisel marks, consistent patterns suggesting systematic carving. But the scale is enormous. Carving 1 million cubic meters of sandstone with hand tools would take an army of workers decades or centuries. Who built the Longyou caves? When? Why? There are no historical records, no inscriptions, no artifacts left behind identifying the builders. The caves are empty. No evidence of habitation, no tools, no pottery, nothing. The local population has legends about the caves. They say the caves are ancient, built by people with great power. But the legends don't provide details, just vague references to ancient times. Some archaeologists speculate the caves were built during the Qin dynasty, around 2,000 years ago. But that's speculation. There's no direct evidence. The caves could be older. The purpose is mysterious. Why carve enormous underground chambers? Some theories suggest they were tombs, but no bodies have been found, no burial goods, no typical tomb features. Others suggest military use, underground storage, barracks, defense. But the design doesn't support this. The caves are large open spaces, not suited for storage or defense. The most baffling aspect is the lack of documentation. China has extensive historical records going back thousands of years. If a massive excavation project involving 1 million cubic meters of stone occurred, you'd expect some mention in historical texts. There's nothing. The Longyou caves exist without any historical context. Massive engineering achievement with no records of who built them or why. The engineering itself is sophisticated. The pillars are load-bearing. The spacing and dimensions are calculated to support the ceiling weight. Whoever built the caves understood structural mechanics. They knew how to prevent collapse. The Longyou caves represent construction that shouldn't exist without documentation. The scale is too large, the effort too immense, the precision too high. Yet they're there. Undeniable, unexplained. Moving to the final two structures in Part 5. Structure number 9, Derinkuyu, Cappadocia, Turkey. Beneath the city of Derinkuyu lies an underground city, discovered in 1963 when a modern resident knocked down a wall during home renovations and found a hidden room behind it. That room led to tunnels. The tunnels led to more rooms, and more, and more. An entire city, underground, extending over 280 feet deep into the earth. Derinkuyu could house 20,000 people, with livestock, with food storage, with water wells reaching even deeper than the city itself. The underground city has 18 levels, multiple ventilation shafts ensuring air circulation throughout, water wells at various depths providing fresh water, kitchens with chimneys channeling smoke to the surface, wine presses, storage rooms, meeting halls, even schools and churches. The city could be completely sealed from inside, massive circular stone doors, rolled into place to block passageways, only openable from the inside, designed to withstand siege. Who built Derinkuyu? When? Why? The soft volcanic rock of Cappadocia is relatively easy to carve. That explains how it was built. But the scale is staggering. Excavating 18 levels deep enough to house 20,000 people requires moving hundreds of thousands of cubic meters of rock. Where did it go? Like the Longyou caves, there's the question of displaced material. That much excavated rock should leave evidence. Piles of debris, nearby structures built from excavated stone. The landscape should show signs of large-scale excavation. It doesn't. The rock seems to have vanished. The oldest parts of Derinkuyu may date back to the Hittite period, around 1400 BC, but that's uncertain. The city shows use by different cultures over millennia. Byzantine Christians definitely used it, but they may have been occupying and modifying something much older. Why build an underground city? The standard explanation is defense. Cappadocia was frequently invaded. Underground cities provided protection, but the effort required seems disproportionate. Derinkuyu isn't a simple shelter, it's a complete city, with infrastructure, with sophisticated ventilation and water systems, with the capacity for long-term habitation, What threat required 20,000 people to hide underground for extended periods? Invading armies are a surface threat. You could fortify surface cities, build walls. Underground seems like overkill for typical warfare. Some researchers suggest natural disasters, earthquakes, volcanic eruptions. But Derinkuyu isn't built to survive earthquakes. Carving into rock doesn't make you safer from seismic activity. It might make you less safe. The ventilation system is sophisticated. 52 ventilation shafts, some extending all 18 levels deep. Air circulation throughout the city. Without it, 20,000 people and their livestock would suffocate. Designing such a system requires understanding of airflow, of how to circulate fresh air through multiple levels without fans or mechanical assistance. The ancient builders engineered natural ventilation for a massive underground complex. Derinkuyu isn't alone. Cappadocia has over 200 underground cities, smaller than Derinkuyu, but following similar designs. Many are connected by tunnels, creating an underground network. The effort to create this network is staggering. We're talking about excavating enough rock to house tens of thousands of people across dozens of locations. The labor requirements would be enormous. Derinkuyu represents engineering that exceeds simple defensive needs. The scale, the sophistication, the network of connected cities, its construction that suggests a major regional effort over possibly centuries, but we have no clear records of who built it or why. Moving to the final structure. Structure number 10, Yonaguni Monument. Japan. Off the coast of Yonaguni Island, 25 meters underwater, a massive rock formation discovered in 1987 by dive tour operator Kihachiro Arataki. The formation looks artificial. It has straight edges, right angles, flat surfaces, platforms, steps, terraces. It looks like a submerged pyramid or temple complex. Marine geologist Masaki Kimura has studied the site extensively. He believes it's a man-made structure, carved from bedrock, built on land, then submerged when sea levels rose. If it's artificial, dating is critical. When was it above water? Sea levels have risen significantly since the last ice age ended about 10,000 years ago. The Yonaguni Monument would need to have been built before the area flooded. That would make it over 10,000 years old, predating known Japanese civilization by thousands of years. Skeptics argue the formation is natural. Sandstone erodes in layers. Tectonic activity can create angular features. The monument could be natural erosion that happens to look artificial, but some features are hard to explain naturally. There are apparent tool marks, holes that look drilled, channels that look carved, a stone feature that resembles a face or head. One section shows what appears to be a road or pathway, flat, straight, leading between terraced levels. Natural erosion doesn't typically create roads. Kimura and his team have identified what they interpret as a castle, a shrine gate, and a stadium. Obviously controversial interpretations, but they're based on specific features that have geometric regularity difficult to explain as erosion. The formation is large, over 150 meters long, 27 meters wide, complex. If artificial, it would represent massive engineering effort. Why build it? If it dates to 10,000 years ago, that's the end of the last ice age, a time of rising sea levels. Coastal communities would have been retreating as the ocean advanced. Why invest in major construction in an area about to flood? Unless they didn't know it would flood, or the construction is even older, built when sea level was much lower, before the ice age ended. The debate continues. Mainstream archaeology leans toward natural formation. Alternative researchers see artificial structure. The truth is probably somewhere in between. Some features may be natural, others possibly modified or enhanced by humans. If any part of the Yonaguni Monument is artificial, it challenges our timeline. It suggests sophisticated stoneworking existed over 10,000 years ago, in a location we don't associate with ancient advanced cultures. The monument remains underwater, slowly eroding. Each year makes study more difficult. Each year natural processes obscure potential evidence. If it is artificial, we're losing the chance to understand it. Yonaguni represents a mystery beneath the waves, a formation that shouldn't exist if natural, a structure that shouldn't exist if artificial. Either way, it challenges our understanding,